Good morning, good afternoon, good evening. Today we will make a control for three-phase Dahlander or pole changing motor. This connection for three-phase windings, particularly for three-phase motors, uh, were designed and discovered by a Swedish engineer, Mr. Engineer Robert Dahlander, and some of his friends around late 18th century. The idea here is to control the motor in two speed, usually in the ratio 1 is to 2 or 2 is to 1 number of poles. If we know the formula, speed formula of a three-phase motor, it says that uh, the speed is equal to the number of the frequency, or the voltage frequency, the constant 120, and the number of poles. Or in other ways, this is represented sometimes by frequency 60 and the P is pair of poles. Here we will use the 120 and the poles is number of poles. If you use 60 here, in some book, in some presentation, the P is pair of poles. So if you have two poles, that is only one, which is still the same. We will connect the motor in two poles and four poles in this example. A basic motor, small motor, 24 slots, 36 slots, maybe from 1 horsepower up to 5 horsepower. The default connection here is series delta based on US standard. This is just actually labeled 1, 2, 3, 4, 5, 6. Only 6 terminals were brought out outside the motor's terminal box. We can convert this one into T1, T2, T4, T5, T6. This is IEC and European standard later. Uh, Say for example, this we are going to connect this one in series delta or low speed course. We know that delta is connected this way. Uh, there are two ways to connect the winding in delta. The same time also for star. Well, this is the default connection given by the diagram. So when you say two poles, we have one north and one south. While the other one is four poles, you have two norths and two souths and magnetic polarity of the windings. More on that later. We will first do the connection if we are using magnetic contactors or electromechanical switches. Of course, there are some applications for this one, and this is not always uh, suitable for all applications. There are disadvantages because of the sudden change of RPM from low to high or from high to low. So there are specific applications for this motor. Let's say for example, we do this one. You have the series delta. Then next we are going to open the K1, connect K2 and K3 later. So that is equivalent to double star. So here we're going to see this is the default connection, meaning these terminals can be reconnected using magnetic contactors, or you want to test this one without electromechanical switches. we are going to do this way. But when using magnetic contactors, we are going to connect this way based on the standard connection. So the default is this one. We will just interconnect the electromagnetic switches. Okay. If we are going to convert this one into a three-phase UE standard, we will place here T1. The output will be the standard T4, and this one will be T7. Of course, we cannot see that one there in Mr. Uh, Dahlander's connection. So we will translate first this one. So actually we have two sets or two groups of winding. And if you have the 12 lead standard, this will be 11. For simplicity, we can use this one, but always refer to the nameplate of the motor, what are the standard labels. This will become T2 also. And the output of T2 is, we know that was, so that is T5. And under T5, we have, this is 7, 8. This is T8. Of course, uh, do not use this one as an ordinary star delta connection. It will not work. This is 10, this 11, T11, this is T10 actually. And if we have this one as 1W, we will have this one as T3. The output of 3 is T6. And we will have this one as 9. And this is the T12. If 12 terminals are brought out, so you have this one, 1 to 12. But only 6 terminals are brought out outside the terminal box in this standard. And they are already interconnected inside. Which means 1U or T1, this one, T1, 1U, 2U, 1B, 2B, T2, T3, and this one, 2W, or they are already interconnected inside. Okay. Say for example, this one will form the connection at 2U, 2B, and 2W. Means you are going to connect this one here. Okay. The sequence here is 1, 1B, or T1, T2, T3 to the lines, and these two conductors are open. Now this is the double star later. You notice this one will form a line, this one will form a line, this one will form a line, and when you short this one out, it will form a double star connection, which is equivalent to this one. That 1U, 1B, 1W. Next, so this will be the star connected for double star connection. Okay, this one for the lines. That is 1U, 1W, 1B. You can have this one interchange, line 1, line 2, line 3. But during the transition, be sure they have the same line so that it won't reverse. So if this one is line 1, so this will be line 1 also there. Wait, we need how many contactors here? We will do it later. If we need isolating contactor for more safety. It's up to you in your design. But I usually refer the isolating contactor. Okay. Next, if this one is K1 and that will power this one, we need this one to open. And this one also. This will be connected here because it will form a star connection there. Anyway, you're going to connect this one here, no problem. You're going to connect this one here, no problem. It depends on your actual wiring space requirements. So you can interchange this one because you have the connection short circuited only. We will connect the overload relay later. Where are we going to connect this one? Okay, the sequence is K1 on, this one are open. Next, disconnect the line, this one, and this one on, and this one is on, forming a double star. So if we need the line contactor, we have to add that for safety. Let's say, for example, we want this one as the line contactor. The controlling or line magnetic contactor, sometimes called isolating contactor. You may add or you may not want this one for additional cost, but usually this is added for additional safety. Okay, I want a contactor that will isolate the whole contactors. So I will make K1 as my isolating contactor. And this one will turn on the low speed. So I need a contactor here to isolate this one. This is for additional safety, of course. Okay, we have to series the two power contacts. So in this circuit now, we can identify where are we going to place the overload relay. It should be here. Why? Because this is always closed. And we're going to disconnect this and connect this one here. Remove the dot and connect it. Okay. So K1, so we will make this one as our, let's say we make this one as K line, KL, or the isolating contactor. Why we usually put this one? And in reality, the isolating contactor is located higher than this contactors in the control. That is in the design process. Usually when there are floodings and the circuit breaker is still turned on, of course there are power here. If this one is placed under the machine, let's say a late machine, so usually some of the panels are reachable by the floods, something like that. So the control should be higher. Next, KL, KL, K1, K2, K3. So we will turn on K1. Open, open. Outside the working area. standard start stop. Okay, K1 is on. That we need a control for KL, K2, K3. So we will make the KL we can replace them. This is KL and this will be the controlling contact of all the contactors. That means all the controls is all the control the contact auxiliaries under this two momentary contact. So may contactors, four contactors. So we need two more. If the transition from low to high speed is semi-automatic, no timers, you can use push button. We will use the semi-automatic transition first, no timers. Okay, let's say like this. 1 and KL parallel. Okay, the sequence is on this two, open this one, then on this two. Okay, we need normally close push button. And normally close contact. Normally open, normally close. And the brake double circuit push button in ONC combination because we want the transition to be push button operated. You can use timer, it depends on your design. Let's say for example in a turning machine, there is an option there for automatic and semi-automatic transition. You will use the manual lever switch for low speed and high speed. We need interlock here and we need the normally closed push button. This is double interlock always. One of this contactor will interlock this one. Now, there are several ways to control this one. Like to close this one first, open or close transition using resistors, and turn on this one first. Or you can turn them on together, which is according to the size of the motor. If the motor is just small, so you can just open transition. If it is so big, that will surely impact the mechanical load of the motor. I mean, the mechanical load will impact the restarting or the mechanical jerking of the motor. We will turn on this one. At the same time, we will latch this one. So this one is here. You need latching. You will see. Just add so many contacts if you want. Then streamline later if you solve the main function. Add so many contact relays if you want. Whatever you want. Then streamline the function later if you already make the standard operation and be sure to be uh, using the safety precautions and interlock. Let's say K3, K2, and this is K2 or K3. This will be K2 and K3. We'll label this one as uh, okay, high speed. High speed post button switch for high speed. This one is the start or the low speed. We'll try outside the working area. Series delta. Now you decide the operation. Open first. Why we are going to open that one first? Because we are going to short this out. You are not going to open that one first. This is short circuit because this two will operate. Next, you can see this one in let's say step operation. What happened here? Did we miss some latching contact? K2, K1, KL should be always close and K2 will... Wait. Not the one. Since we open this one, so we are not going to place we're not going to place this one here, but here below. But this is also aligned. Because there is always a power there. Okay, so this one is here, this area. We're going to bring this down. Remember, this one is the line and this one is shorted out to form a double star connection, parallel star. So this one is connected here. Okay, that way. Bring a bit further. Okay. So this one now is shorting out this one. You can short that out because this one will open. In this case, that is one line. We have line. This is line from one leg of star, another line from the one leg, two legs, another to the second, third phase respectively, and connected to the this forming the two star joint. Okay, open this one, and this will be short out by K3, and this one will do the line 2U, this one 1, 2, 3 lines, and this one will be shorted out, forming the double star. Okay, we'll try. And you will decide semi-automatic. Where is K2? Like K2 is not in operation. We have open circuit. We will see. Hmm, this is so wrong. Oh, that's fine. Okay, troubleshoot. That was the open circuit there. Now we have here the interlock. If your option here is the momentary push button or this one, you can have this one, you can have this one. It depends on your design. Sometimes some will prefer this one because they can see the switch is locked. Because the momentary push button, you cannot identify that it is in the symbol of high speed, especially the lever type handle in some machines. So we have now the line 1, line 2 connecting the two inputs of the star, two inputs of the star. No current there because same polarity. And this one is forming the double star. This is it. For automatic transition, you can have the timer. I simulate overload relay, but we don't have overload relay. We are going to place that here. Since we are using one motor, one overload relay is enough. You can add if you want, but connect them properly and set them properly. That is expensive and sometimes useless. Usually you can find them in some of the diagrams here. There are so many. In every contactor, they are placing one overload relay here, one overload relay here, one overload relay. It's not like that because you are only controlling one motor. But again, how many settings of overload relay we are using? That is the importance now of this line contactor or the isolating contactor. All the currents will flow here. During the low speed operation, current will be here. You don't want to transition from low to high, the current will be sensed by overload relay. If you want the high speed, the current will flow from this to this contactor. And since this is star connected there, all the currents there for the double star is via contactor to contact and to overload relay. What's the point of overload relay here, overload relay here, overload relay here? So many wrongs of the diagrams here without that actual configuration or connection in reality. Just note that one motor and one overload delay is enough. Just set them properly, compute them properly based on the motor's data. How does the motor change from two poles to four poles? We'll talk that one in the next video. It's a bit complex, but really it is based on this characteristics. But the internal connection of the motor windings inside stator is a bit complex. We need some mm, four poles, not two poles theory and magnetic field inside the rotational, the 120 electrical distances or mechanical degrees. For automatic transition, you can use timer. If it is already fixed, that means you fix your application. If you fix your application because you want to start at low speed, then it will go to high speed. And you use timer. If the operation suggests that you need the low speed sometimes and you need the high speed sometimes, use the semi-automatic transition. That means you have the choice to connect to operate from low to high speed. There are several ways to make the switch. You can have a toggle selection, selector switch, as long as it is safe. Again, in some operation, you are going to close this one first, actually for bigger motors, and this one that requires some close transition or some timer operation there. This one is the basic operation, not good for all sizes of motors, okay? For small sizes of motors, you will step the operation to see the transition of the contacts. 1 km forming the surge delta low speed. Release this one, this one will latch permanently. Then we have the option to change from low speed to high speed. Open this one first, then close this one. Let's see, open. There will be no power there. The software memory is that one, but no power. Okay, this latching contact, by the way, not interlock, but these are interlock. You have the option to use this one if you are using the normally open push button. If this one is used, then you may omit this one. Emulate overload delay. Okay, you may add some signal there, lamps, or even this one. You can add simulation lamp there, pilot lamps. Do not reset the overload delay, but find what causes the tripping or the overload or the overcurrents. Turn off circuit breakers. Okay, this is it. Next, I will explain the interconnection of 2 and 4 poles inside the stator of the motor. Thank you. Thank you to my subscribers. 20 strong subscribers. Thank you. Hope you may have a good day. Until next time. Bye bye.